Welcome, everybody, to the Summit Podcast. My name is Alex Hanna. Today with me, I have Jacob Edmond. Jacob, why don't you go and introduce yourself?
Hey, yeah, thanks, Alex, for having me on. My name is Jacob Edmond. I am CEO of Duck Works Millwork Solutions and also podcast host of Verifying Field, the Millwork podcast as well. We had you and your colleague on Jeff on our podcast a couple months back as well last year. So
yeah, definitely. If you guys want to check that out, Jeff Drews and myself are on that podcast with BIM. Kind of talking about tech with cabinets and how you're realizing architects and stuff are wanting coordination with millwork for their buildings. You want to kind of talk about that and why it's happening?
Yeah, absolutely. So I focus mostly in the millwork field and millwork manufacturers in mostly in the US, a little bit in Canada. And a lot of them are commercial manufacturers. And in that industry, there's a lot of large, either, multi-tenant, multi-floor, multi-story buildings, and or even in government, courthouses and stuff like that, where the architect and the client are requiring BIM coordination of all the trades. And the trade that we work with being millwork, that are putting in the cabinetry and the woodworking and the trims and all that stuff. Normally those manufacturers are really just worried about detailing that stuff in their CAD and CAM software for their own purposes, and they just kind of, the PDFs of the drawings is what's sent for approvals for coordination. But with the BIM coordination requirement, it's, hey, we need to get your products modeled in BIM so that we can pull it into the central model for the whole job. And so which makes sense a lot with a lot of the other trades, HVAC, electrical and stuff, so that everybody can see all in one central place. And with millworkers, they're used to kind of being last and more like, okay, well, it's not done until it's done. And so the tricky part there is with BIM models, it's hey, am I actually giving you guys what we're going to build? And a lot of times it's kind of that chicken or the egg of, hey, getting it coordinated enough to give you an accurate model. But it's also an industry that's not used to working in BIM and Revit. They're used to just a lot of 2D, a lot of even on the fly pencil whipping the last few details and stuff.
Yeah, that's interesting, because I was going to ask, we kind of talked about that too on your podcast, was coordination in the architectural side, right? So I'm MEP side, I'm used to electrical, all that stuff, structural, the big stuff. And then there's this minute coordination. Like on our side, we call it like, internal coordination. If you're doing plumbing, clash plumbing with plumbing.
Okay, yeah.
So it sounds like what's happening is architects are coming in with their own kind of coordination that's happening, meaning they're going to want to make sure that the fixtures that they picked are going to fit, or their cabinets and millwork that they design is going to fit. So I'm interested, what are some of those clashes that you see, or like common ones that happen, or like the ones you just want to like smack your head and be like, why the hell did you do that?
Yeah. I mean, the most common is, I would say, is probably plumbing. In almost every job, there's at least one break room or bathroom vanities or something where the millworker is providing cabinets or caseworker, even the countertops. And, there's plumbing by others. And kind of the general way it works without BIM coordination is, okay, well, the millworker gets the architect's drawings that says, hey, I want a break room wall of cabinets here. In there's a sink cabinet where the sink needs to go. The millworker will do their shop drawings, send it back to the GC and architect that says, hey, here's the center line of where we think the sink should be. The plumber does his own stuff separately. They never really talk to each other. And so the GC or architect is kind of looking at both and saying, yeah, and it really is probably some project engineer at the GC. Yep, that looks good. Yep, that looks good. And a lot of times as the millworkers will get the approved plumbing submittal. And, our job in the millwork as engineer and design is to say, oh, shoot, that sink that you approved is too big, or, okay, it's going to work. But really the coordination happens when the millworker goes out into the field after the plumbing is installed, takes a measurement and says, okay, and takes that back and puts that in. That's the old school way that still, I'd say, most are doing today. Somebody goes out in the field, takes a measurement, translates that back to the engineering, and they put it in and say, yeah, that falls inside of my cabinet. As long as it's inside of the two sides of the cabinet, usually the plumber can make that work, right? I put a sink here, I put my cabinet in there, the plumber then connects the two later, right? The idea with BIM coordination is all of that wouldn't require a trip to the field. And if anything, you would have that clash detection. So that's the most common example, plumbing. Similar to that, you're going to have electrical or, more complex plumbing. Sometimes there's like in a school, for example, now you've got science classrooms. There's a lot of utilities and things. You've got gas, you've got water, you've got bubblers or water fountains. Where it gets more complex is a lot of jobs, hospitals and things like that. They want to close in above the cabinets. So sometimes the millworker is providing enclosures that go all the way to the ceiling. And then you've got HVAC that might be enclosed in there. Or similar, there might be a soffit by, the GC that gets drywalled, and then we've got to fill the space there. So it's kind of that coordination of where does one trade stop and another trade start? And sometimes then there ends up being the other trade saying, oh, hey, you're going to have this closed in. Can I stick something in there that's going to be hidden anyways? So HVAC, and in higher end jobs like casinos or things, there's a lot of ceiling work the mill workers get into. And so then you get into, fire suppression, HVAC, obviously, and lighting and a lot of stuff that then, I've done casino ceilings where we're covering the whole ceiling in trim or panels and things like that. And so we actually have to know where everything that's got to come through there. So fire suppression, sprinklers, lighting, and all of it's got to line up. So that's where it gets more complex. And even with BIM coordination, you still probably end up with, hey, I'm going to make a template and make sure it's exact and not off by 1/8 of an inch. But that BIM coordination goes a long way, because that's really the only way. Really what the goal of it is that the architect and the GC, who aren't going to go to the field for every single trade necessarily, they can see early on, hey, this is the way I intended it, but is this actually possible that I can align these things to where these two trades can make everything match up the way I envisioned it?
That's so interesting. Like, that's nothing that I would even consider. I've worked on projects that I think would have millwork in it, but I've never seen it in the coordination as we're doing it. So everyone listening, let's start making that a normal thing. If your project has millwork in it, get them on all these coordination meetings, the MVP and everything, and start getting them involved. I was going to say, I've worked with a trickier situation with modular. So a lot of times modular floor framing has your, your edge beams and your long beams and stuff, and you can't penetrate any of that stuff. And if you put a cabinet on a wall, we're talking 2x, 6 inches and 4 and we'll say 5 and 6 1/8 or 6 1/4, whatever your 2x6 wall is, and you got to put a 3-inch or a 2-inch drain in there. So very often we retrofit those cabinets with like little cornerbacks that fit inside the cabinet that hide that plumbing that's all coming through.
Even structural a lot of times, because like a lot of times there'll be a multi-story thing where it's kind of like, hey, we've got these typical offices or these typical break rooms, but then you end up in one of them where there's a structural column that maybe after the architect's initial design, then the structural engineers come in and say, hey, we actually need this column to move over 2 feet or whatever it might be. So we've had tons of them, like you're saying, where either there's plumbing or even structural stuff that in one random room, we've got to make a cabinet a weird shape to avoid that.
Do you use any tech? Like, do you go in with like a BLK Go or a laser scan of any kind to? Okay. So what software are you using?
Yes. So the most common that I've used in the past that a lot of people use are a BLK. Well, there's BLK 360 now, but there's the oh man, what am I? There's
the Go.
There's another one that's lower tech, but it's a large red. Why am I blanking on what it's called? But like a 3D disto, the 3D disto.
Oh, okay.
So the 3D disto is more accurate at a distance than like the BOKs are now. So the BOKs can do, so like the BOK 360, which is I think like 20,000 or something, right? Where you can just take it and it does a full point cloud, right? With photos and stuff in it.
So before we move on here, I want you to explain for our listeners point cloud, laser scanning, disto? Like,
Okay.
how are these all different? What are they? And I want to hear from you, because like you and I talking, us talking in the industry, we throw these terms around like nothing, and then your wife asks you what you do for a living. You're like, I make pretty pictures, So why don't
Yeah.
you kind of go into that a little bit?
Yeah. So and I guess even a further step back, what we're talking about are essentially lasers that are used for measurement purposes, but it's gotten further than that, right? And so you go all the way back, and Leica is one of the brands I was referencing. There's others that you can get, but within Leica and within all these, they have different types, and so they have very, very, very accurate types that you think like even surveyors use. But on construction sites, I can tell if I'm out of level on a slab, hundreds of feet away. Okay, there's that level of accuracy. The disto that I mentioned, which Leica has a whole family of lasers that are distos. And those are more common, like lower tech. Like there's one that's handheld that I can literally just point and take a measurement across the room, right? So there's that. Then there's ones that you're going to put on a tripod that can actually feed measurements into CAD, or a CAD-like software, right? So you can actually go out with a tablet or a laptop connected to this, and I can there's the manual point shoot ones where it's like, okay, I'm linked to the laptop, and I know where I am in CAD and space. I've got some reference points, and I can point it, shoot a laser. I can see where the laser's pointing at. So, yep, I want to measure from here to that wall, and it'll record that in CAD, right? And there's like the 2D version of that. Then you get another level higher, and you've got 3D where I can go up and down, left and right, and auto scan. And that's the 3D disto. The 3D disto has that plus photos, right? So it's not a full point cloud, but it can kind of create a simplified point cloud. And so, and within this, there's kind of accuracy levels. So I think the 3D disto can measure within a millimeter of accuracy at either 50 or 100 meters, something like that, right? So generally, in any room I might need millwork, I can put it in one place, and I can take measurements to all the walls and be accurate enough for millwork, meaning that even for countertops, it's used a lot, where you don't have a backsplash, and I want to scribe that countertop to the uneven drywall face. So that level of accuracy to some extent. Then you get into point clouds. And so now, like, for example, they have a family of the BLKs. So BLK 360, they even have one now that sits on a drone that flies around. And those are designed to make a full point cloud. And what a point cloud is like, it's literally scanning all the surfaces it can see. So if I'm a laser and I'm sitting here in space, I'm going to shoot out all around me so fast and record everything that I see, right? Kind of like sonar or radar, I guess. I'm outside of my technical expertise. But what it is doing is it's recording that into CAD, and I get a point cloud, meaning I have thousands of points of reference that are literally in space in a CAD model that I can go and reference. And with that, it can actually pair that with photos and using software like what is the Autodesk software? Recap Pro, is it?
Recap Pro, yep.
Yeah. It can take that point cloud data and put it in a model where you can go in and you can actually orbit around in the space. And so a lot of times you see these now, they get put into Matterport. You even see on Realty websites sometimes now where you can do kind of like a dollhouse, right? So photorealistic wise, it's like you're in the space. That's really valuable for coordination of just like, hey, I want to know where the window is relative to the wall. I want to know, is there an outlet there? I want to know, right? And you can get pretty accurate measurements even. The accuracy is not as accurate as the previous kind I mentioned, where it's like 1 millimeter at 50 meters. I think the BLKs are more like 5 millimeters at 50 meters or something. So it's pretty good. But if I want to actually get accurate enough to like, do I need to scribe that countertop? It's not that level of accuracy. So all of these serve a good purpose. That BLK stuff that I just described, the point clouds, for most mill workers, the people I work with, and if any of them are listening, there'll be some people offended probably, but it is one, too expensive for most of them to justify. You're talking about at least $20,000, $30,000 investment up front, much less the education of how to use it, the software. And then you still have to figure out, okay, how do I interpret that into something I can do with? And usually the amount of data you get from that for the purposes it would be used, I could probably just put a 3D camera, 360 camera in there and get almost the same thing, right? It's not the point cloud, but I can see, hey,
Right.
what's in this room? So what I've used mostly, and what most mill workers will use if they go that far, is the 3D disto. And why it's really good, and the way I've used it in the past, is one, I can get accurate measurements. So if I have ceiling panels in this room and wall panels and some cabinets along this wall and a countertop, I can set my laser in the middle of the room and I can drive it from my tablet and I can auto scan. So I can set it up and say, okay, just scan all the way around linearly at a height. So if I want to do it at where my uppers are, for example, I can do a 3D scan and it'll I can say, here's 4 points on the wall, scan everything in the middle at this interval. So I can set a grid, say I want to take points every 6 inches, every 12 inches. And it's just, the more tight you are together, the longer it's going to take.
Right.
And then it's going to manually drive itself and do that, right? With that, I can also take photos. And so what that spits out is like a 3D CAD file that I can actually pull into CAD with, if you're familiar with CAD. And I know I'm dumping a bunch of stuff real fast here, but
no, this is all okay. So just a quick reference, I was looking into distos a while ago because we were doing facades on houses and trying to do some linear cuts for siding and things like that.
Yeah.
And I was looking at the manual point and shoot because that one writes right to CAD, creates a DXF file, which is basically just a plane. And if I shoot points, it sees depth. So if I say it's that deep and then it's this deep, it makes the facade like this. It doesn't make a short little angle. So I was 100% looking into these. The Disto 3D is something new that I haven't heard of. So keep going. This is super interesting.
I think the 3D Disto is kind of like the best of both worlds. And it's probably about a $10,000 investment now, the software and the thing and all the stuff. And you can actually rent them as well, which is how I first started. I'm here in Atlanta and there is a Leica dealer here. And so when I was trying to convince one of my companies to buy one, I rented it. But that's the nice thing, is it's pretty versatile. I can even, one time I was doing a spiral staircase, or like a curved staircase, and I needed to measure the stringer that goes up and it curves. And so I set it, and I was able to pick 2 points and say, go on a line, and it would follow the stringer. And I said, I want every 2 inches. And then I left it, and it just did that. And it's just going to take those points. So I'm going to get a 3D model with that exact spiral curve in 3D, right? I take some points of the floor, so I have reference. I take some points of the wall, and then I can take that 3D model into my, if I have a Revit model or I have a CAD model of my floor plans, I can reference it to everything, right? And then beyond that, I would manually point and shoot some things. So like when I had to do ceilings, I would point and shoot the center of a sprinkler, and I would take a picture so that when my engineer got it back in CAD, he would know what that point represented and some context. So that's the nice thing. In CAD, you have actually these XREF images that it took at the point where they're taken. So I can snap a point, take a picture, snap a point, take a picture, and you can do that as many times as you need. So it's good to kind of mesh the two, because a lot of times a field guy is taking this, uploading it, sending it back to somebody in the office who has never been on the job site. So that's how we used it a lot. The coolest time that I used a 3D Disto was I had to fly down to Miami for a job site, and it was like we were way behind, and I needed to get in the job site to measure what we were doing. It was actually like NBC headquarters, one of their television studios they were building, and so they had this big indoor atrium. And the day that I flew in, it was like I was flying in, going to the job site, taking a bunch of measurements, flying out. And that was just actually when I rented the Disto. So I carried it on with me because I was like terrified to check this hard case. So I get to the job site and I had to measure. We had in the interior courtyard area, they had these big curved planters and benches that we were covering with millwork and stuff. And the area, one of them that I had to get to, they were coating the flooring with some sort of like poly coating. And they were, like when they're pouring concrete, these guys were on spikes. So I couldn't go there. I couldn't walk over there. So these guys that were working on it were walking on spikes. And I was like, hey, I need to get measurements over there with my laser. And they were like, sorry, you can't come over here. And I said, okay, if I hand you the 3D disto, it's this like coffee can sized laser. I said, if I hand this to you, can you put it over there? I'm driving it from my tablet across the courtyard and I can see what it sees on my tablet. So they were 100 feet away at what I needed to measure. And I gave it to the guys on the cleats that were working. I said, just set it on the wall over near there. I'm going to do what I need to do. And when it's done, you can bring it back to me. So that was like the coolest thing, because if not, I wouldn't have gotten those measurements that day. And so I was 100 feet away and I'm just driving this thing on my tablet, and everybody there, all the other trades were like, what is that? What are you doing? Oh, where do I get one of those? And this was probably 8 years ago now, but
yeah, some technical difficulties, but we're back. Jake, why don't you kind of tell me where you came from and how you got started and like how you ended up creating Duck Works?
Yeah, absolutely. So I went to college, university for architecture, and it was one of those, high school guidance counselors and friends, and everybody was like, "You're good at art. You're good at building things. You're good at math. You'd be a great architect." I was like, sure, I think I'd like that. And by the end of architecture school, I really didn't want to be an architect. I really liked what I thought architecture was. And I'm offending half your audience probably, but
currently it's just me. So,
but architecture school is different than architecture. And I worked as an intern for a small firm that I loved. And I loved what architecture really was intended to be, but in school, it can be very different, at least where I went to school. And actually my last semester, I had a design build professor, and he really kind of brought me back to understanding, okay, I like the design process, which is what I learned in undergrad. I didn't go through with my master's, my professional degree, but what I really liked is the design process and understanding how to help clients solve problems, and that they think they have the solution to. And what happens a lot with architecture is a client will come to you and say, hey, I really want a building that looks like this, or I think I want my house, that looks like this other person's house I saw, or I want to solve this problem. And they give you what they think the solution is. And you kind of work through a good architect or a good designer, really anything is to kind of help them understand, hey, what is the core problem you're trying to solve? What is your goal? And then let me help you get to the best possible result that you might not know is possible. You don't know what all options are out there. You don't, and that's very much what we do really in any of the trades in construction. If people are good at their trade. And so I worked in some construction and I worked in an architect's office. And after I graduated, I ended up at this door company that we built hurricane rated doors. And her little old school style and rail, mortise and tenon, mahogany doors. It was like the full 9 yards. We would send test doors down to Florida. They would shoot 2x4s at them, and they had to be able to resist hurricanes is what it was built for. Yeah, that sounds
like fun.
And so I was doing the CAD design from that. I had, was like applied to a job listing. Hey, we need somebody to do our designs for these in AutoCAD. And then when you're not doing that, you'll be in the shop learning how to build this stuff. I did that for a few years, and but I got to a point where I was like, okay, I want to get back towards, what I went to school for. And I don't want to be, I wanted to keep my fingers, frankly. I was both doing the design, the shop drawings, making cut lists, and then building the stuff. And I actually kind of became the guy doing most of the elliptical and radius stuff, and learned a lot of cool stuff through that. And then I ended up at a cabinet shop, where they use this software called Microvolum. And so what that is it's like a library-based parametric software for cabinetry and millwork, and that overlays in AutoCAD. And so think of it's similar to like families in Revit, that you have parametric products, which are kind of like in Revit. I guess it'd be families. I don't know what you would call a cabinet inside of a family. That is a family, right?
It'd be a family, yeah.
And so, but it gives you both what you need to draw in 3D and in 2D for like your shop drawings, and then what you need later to send your production to your machines for CAM and everything. And that really was like, oh man, I love this. It kind of took me back to some of my architectural basis, because also when I was in architecture school, it was when they were first starting to kind of teach Revit a little bit, and they were shifting from Form Z to Rhino. So I learned a little bit of everything, and I really took to Revit. I liked it, and a lot of my classmates were doing like either SketchUp and Photoshop to do their renderings, or Form Z and Photoshop and stuff. And so I was really like, well, if I want to be an architect, I want to learn Revit. And then I found this microvellum. I was like, this is really similar to Revit, but like, I'm going to design it today. We're going to cut it tomorrow, and it's going to get installed next week. And that, like, I loved that. I really loved seeing, because what I hated when I was working as an intern architect was like, I would spend months doing these contract documents for this custom house in a lake, and I would never go see the thing get built. It was like, okay, we've designed it, hand it over to the GC, and they're going to build it, and then I'd be on to the next one, right? And
Yep.
what really got me into architecture, what I thought was like, oh, I love going, I worked construction and doing stick framing. I loved walking through a building being built. I loved seeing that process.
Mm-hmm.
So when I got to my first millwork shop in cabinetry and was like, okay, I'm going out to the job site, and it was a real small shop. So I got to go meet with the architect and had handoff and like, okay, this is what you want to do. I'm going to go do the shop drawings. And I'm going to go once the walls start going up, and I'll take measurements, and then I'll go update my stuff, and then I'll go measure the materials, and then I'll send it to the CNC, and I'll go talk to the guy building it. And hey, this is how this needs to be changed here, all that stuff. Right.
Mm-hmm.
So that really, I really enjoyed that whole process of being able to like from start to finish.
Yeah, I think there's something to be said about the sense of pride you have when you can see what you've done on a computer and then go and see the project.
Oh yeah.
Like my experience back in the modular factory. What was really great is what I'd be designing on the computer was right there outside my window on the shop floor, which was actually extremely beneficial for learning as well, because technically that's the field.
Yeah.
And a lot of my guys, I'd be like, yeah, go out there and ask them how to do it, or like, if you need a breather, get up and walk the shop, like see what you drew.
Yeah.
It's really fun to like walk around, and even though you don't see it stacked and everything, you can go see the finished product and be like, yeah, I know where every stud is in this building. I know that particular box right there was the biggest pain in the butt.
Yeah.
I hope to never see that one again, but that one over there was awesome. And so you get your kind of the same thing with your millwork. Like we had a cabinet shop in the back. And so we developed custom families that would output all these lengths and cuts, and it would be that extra, 30 seconds big because you had to sand it down and finish it. And so that took months just to figure out, because it was all in one guy's head. He was all back there doing everything. And so I can see a program like Microvellum, was it?
Yeah. Yeah. Microvellum.
I can see something like that being extremely beneficial. Does that run any of the CNCs or saws or anything, or is it strictly just for design and shop drawings?
No, yeah, it does run all that stuff. So it originally started as for just the shop drawings, and then they developed it, and so it is a full CAD and CAM, and so basically it's database driven, and then it uses that data and it uses AutoCAD to model what that data tells it to. But then it also outputs cut lists as well as programs for CNCs, and they'll make posts for any. And so it's one of the ones that's very agnostic to any machine brand or anything like that. So yeah, it does everything, and that's a lot of it takes a lot of customization, just like making families. They make the software able to do a lot, and it's kind of up to the users to develop it. And kind of make it do. So that's a lot of the problem solving as well, is each company that uses it is unique. So just like you were talking about with the modular company, you were building things in your family that were just unique to you guys, unique to that product that you guys were making, the machines probably you had, the way that you guys were set up. And it's just the same with Microvellum is, okay, we have this CNC with these specific tools with these numbers, and we're going to go from there to this other workstation, that's just unique to us, and you can totally customize it to that. And so that a lot was also what I loved, is I would walk out in the shop floor and not only see what I had engineered getting built, but then getting feedback. And some of it was, crusty old guys were like, man, don't ever do that again. I don't want to see that crap. Okay. What do you want to see? I want to be the guy that you guys are asking for me to be the engineer on your stuff. And I like solving problems. And so that was the great part, is when I was learning the software while learning the trade. And like that was one of the things that I really struggled with in architecture school as well, is they give you these problem statements that are just made up. And I feel like that is the worst way to learn to design, is you're not solving a real problem. And so a lot of the ways I learn the best is I have a real tangible problem that I need to solve versus, hey, I've just got an empty square lot that's flat. There's no trees on it. There's no river. There's no road. I can do whatever I want. And there's no problem to solve. It's just whatever. It's a blank canvas. And the most interesting architecture, the most interesting problems are real things that have limitations. Hey, we need to put this on a lot, but we have a step back here. We have a road. We've got egress. We've got access here. We've got a power line over here and a big old hill that goes downhill. So how do we work around those constraints to then get the client what they need? That's the fun stuff to me.
Yeah, I think just BIM in general is problem solving. And it's funny, you were talking earlier about architecture school and how you were converting into Revit. I mean, I'm learning recently now that Revit isn't a main thing that's taught in architecture right now. It's very much an additional or an add-in of like, this is what Revit is. But what's unbelievable to me is the fact that when you're an architect and you go and like you work at a firm, you're in Revit 100% of the time.
Yep. To me, this is the way architecture is taught, and the whole architecture structure, particularly in the US, is just flawed. I don't know how it would ever change, but the way it's structured is basically everything you actually need to know you don't learn in school to be an architect. You have to learn it, and it doesn't have to be done this way. Engineering's not done this way. Almost any other trade isn't done this way for some reason, but architecture school is very theoretical, philosophical in school. And there is good stuff to that, but especially the way there's two ways, types of programs in the US. And I know we're kind of veering off topic here, but
no such thing
architecture,
as off topic.
There's two types of degrees to get a license in architect. You have to have a professional degree. And so there's 4+2 programs where you get a 4-year undergraduate degree, and then you have to go 2 more years in master's degree. Then there's some schools that have a 5-year Bachelor of Architecture, and you can go 5 years. Both of them, though, still require a certain amount of hours of accredited work under an architect in specific categories. And you have to log all these hours. It used to be called IDP, or maybe it still is. And when I was in school, it would take you at least 5 to 7 years. You had to take, I think at that time, 5 different tests before you were licensed. So you have to have the professional degree plus these like thousands of hours of work under an architect, plus pass these tests. And it's a rolling window. And so basically, like, I didn't learn, there literally was not an architecture class for any software. As part of one of our studios or lectures, we got like one class on Form Z, one class on SketchUp, like an introduction. Hey, these are the software you could use. Go figure out how to learn them on your own. You're going to have to use them to do the work we require of you, but we're not going to teach you. I literally the only AutoCAD class I took in my 4 years was from the theater department. I went to the theater department because they teach it for stage design and set design. Like, they have to learn how to do it to do design for theaters of like, hey, well, here's my lights, here's all the stuff. So I took a CAD class there and I learned Vectorworks, I learned AutoCAD, I learned WYSIWYG, I learned a handful of things there. But they didn't have that in in architecture. That's where I took an internship where I got paid in the summers, and I was able to work part-time through the year. And I really learned how to draft for architecture. I learned proper AutoCAD, layers, line weights, all that as an intern working for an architect, because they don't teach it in undergrad.
That's absolutely wild. Like, that's, I'm going to teach you how to be an architect, but I'm not going to show you how to be an architect.
Yeah, and it's
crazy.
Expected that you're going to go learn from architects, basically, which has its merits. But so that was one of my frustrating things with architecture school. It was like, okay, and not only that, then I have these professors who are architects that have never practiced. They went to school, they went to grad school, they got an MBA, they became a professor. And so it's this it unfortunately is very common for it to be like students become the teachers that never practice. So there's usually one or two very good professors that everybody wants that practiced at some point. And actually my best professor that I had came to the university, I think my last year there, and he actually wasn't a licensed architect, but he was an award-winning architect. So that's the other thing in the US, you can practice architecture, do everything an architect does, and not actually be a licensed architect. But you can't call yourself an architect unless you're licensed in the US.
That's kind of crazy. So I've always talked about how BIM, just in construction in general, doing Revit, doing the softwares, it is a trade. It is a trade.
Mm-hmm.
Like
Yeah.
it's all on the job training. But right now, the only certificate you can get is, I took the Autodesk test, so I have an Autodesk certified stamp on it. Or you went to college and you got a degree in design or something. But I mean, it's kind of crazy because there's a lot of people that say we got to go to school for it or that kind of stuff. And it's really not. It's really much like, what can you learn, right?
Mm-hmm.
Honestly, the path to get into BIM is probably through the trades or architecture and engineering, right?
Yeah. It's one of those things that unfortunately, like, it's very easy to go and take a bunch of online classes that teach you the basics of Revit, but doesn't necessarily mean you actually know how to use it very well. And there's a lot of people who use it professionally that work in architecture firms in a lot of places, but they don't really know how to use it well. It's just like AutoCAD or anything else, right? I've used Photoshop before. I'm not a graphic designer though. And so that's the thing is like, I mean, how many BIM models have you gotten that you're like, what are they doing in this thing? Like, what is going on? And nobody taught them. They've never had to learn. It's just an intern that's like, hey, you need to use Revit. And I did it in school and now I'm doing it professionally. But there's nobody here that really knows how to use it. And nobody that's teaching me proper. And I imagine just like in AutoCAD, like there's actually published, there's I'm going to blank on what it's called, but there is an organization that publishes architectural standards and CAD. It's like National CAD Standards or something, right? Like that says, here's the accepted, like nationally recognized way you should name your layers. And I'm sure there's versions of that for Revit and for BIM, right? And those are the types of things that, unfortunately, like Autodesk isn't going to tell you that. That's not really their role. They just want to sell the software and they want to make it do as much as many of their users want it to do, right? It's up to each trade and kind of each use case to say, okay, well, this is how we use it and this is the proper way that we've all agreed to use it. We could do a lot of things with it. And then within that, each firm kind of has their own niche things and stuff. So there's always, that's the hard thing with any kind of software is there's always room for people to really screw it up and to really go off the rails and be very disorganized. It's just like anybody's desk, you know. I've managed millwork engineers and users of CAD software for many, many years. And every single time, if their desk is organized, their model space is generally very organized. If their physical space is very disorderly, you go in their CAD model and their model space is going to be a disaster with copies of copies and like, I don't know what's what.
I will tell you
it's
right now.
It's got to be the same thing.
My desk was an absolute mess, but I was organized in the computer on the table. Yeah. Like I had sticky notes and notes everywhere. No, it's funny you mentioned that because I was reading one of your posts about how hard it was to find. I forgot what you called it.
Millwork engineers?
Millwork engineers. Thank you. I was trying to find out what the last one was. So tell me, how would you go about finding a millwork engineer that actually met your standards?
So it's hard for a number of reasons. One, because the term millwork engineer is very confusing. It's very niche because we're not engineers. We don't have PEs. But we're not architects. We're, designers is a lot of times too artsy, not technical enough. But so generally within millwork, we're called engineers. That's what people call them. And there's no school that teaches it. And largely, it's role that is only, you know, created in the last 15 to 20 years as the advent and adoption of CNC software within our industry has become widespread. And so it's kind of most of the millwork engineers that exist today are late career, and they started as cabinet makers or carpenters or, you know, installers. And then they work for a company that's like, hey, we bought a CNC. We need somebody to program it. You know how to build the stuff, well, and you're kind of getting tired of standing on your feet. Here, go learn a computer, learn CAD, and figure it out. And then they develop and learn the software, and that's kind of how it's evolved. So we're really now at a point, though, where that generation is largely aging out and retiring, and nobody's been replenishing them. Nobody's sat down and said, well, all of these guys kind of learned it by accident because we needed it and they were already working here. And nobody's really figured out, how do we just make engineers from scratch, and where do we get them from? And so I've spent the last 10, 12 years trying to figure that out and staffing and training them. And mostly I've figured out, okay, a combination of you steal from other people if they're good. Those are, you know, more and more running out.
Yeah.
You find people in tangential trades that either have building and CNC experience, but haven't done drafting. So sometimes I would get one of my CNC operators. He's got shop experience. He's run a CNC, so he kind of understands the CAM side of things. He knows what things should look like coming to him. And usually CNCs now, you're operating with the CAM software, making small edits and stuff. And so I'm like, okay, I can start to teach you from the back end. Okay, somebody else already drew it. You're going to then finish engineering it, and I'll slowly teach you the CAD side. Or generally, let me get somebody that's maybe out of architecture school or a design program and has CAD experience, especially if they have both 2D and 3D experience. They can usually learn microrealm. Hey, if I've got Revit experience, I can kind of translate those things. If I've got CAD experience, I know how to draw. Most of what we do is largely 2D. Like, you need to draw like architects draw. Use feet and inches. You know, use line weights and layers and that type of stuff. And so then it's kind of piecing together the rest. And that's generally how it goes. And very much in this industry, most people are very averse to, well, if you haven't built it, you can't design it. And you'll still hear that 100, like all day long, every day, right?
For all trades. So
for all trades, right? But the counter to that, I mean, the kind of reverse or inverse of that, or the con is, okay, if you've spent 10, 15, 20 years learning just the trade, you probably haven't spent much time on a computer learning how to interact with software and user experience and all this stuff that takes another 10 years to really get good at that. And so my philosophy has been, okay, if I'm if I'm an owner of a millwork shop, and I think this applies to almost anything else, I have that knowledge in my organization. I have the guy who's got 30 years experience on the shop floor, probably a bunch of them. I've got the guy that's in the field. I don't need more of that knowledge. And the philosophy has kind of been, I need an engineer who has all of that and can work a computer and basically solve all these problems by himself in a single person. And that doesn't exist. And if it does, it's usually a crotchety old guy that nobody wants to work with. And
you're looking for a unicorn,
yeah. And so what I've kind of taken is, okay, well, if that exists, somebody's already hired him and is paying him very well, or he's a problem to work with, or who knows, right? So I need to create a new solution. Let me get anybody that's out of university today knows how to work on computers. Every Gen Z and whatever's next after that, right? If I get somebody like me with an architecture background, or like you with some trade experience, or like, kids these days now that are coming out of college probably did Minecraft. Like, it's very easy for them to think in 3D if they've got that kind of mindset. So the first is the foundation. Hey, can they think visually? Can they think in 3D? Can they operate software? Can they solve problems? Can they do basic math? If they've done some things with their hands, great. Like I built with Legos all growing up, and like I know that I've kind of always had that visual spatial connection, right? That's something you can't really teach. You either have it or you don't to some extent. And and then teach them to ask really good questions. Do they have the attitude that they're willing to be corrected? I spent 4 years in architecture school getting my models torn apart by professors and told my presentation sucks and this is what's wrong with it. And that's very hard for a lot of people to do, is to sit in front of a 30-year tradie telling you why everything you did was screwed up and not argue with him. Say, yep, okay, let me find the kernel of knowledge in what you're telling me through all the profanity and go fix that, right? That's the hard thing to teach. So if I can find somebody that can do that, that can take a beating and learn something from it and say, okay, that wasn't cool, right? We'll talk to HR about that later, but now I'm going to go figure out how to solve this problem and I'm going to get better for it. If I can find somebody that, they can go ask a million questions to get the answer that they don't know. They can go to the guy on the shop floor. They can go to the guy in the field. That's what we need a good engineer to be. I didn't have all that experience. I got it by doing and by asking questions. And so that's what I believe makes a really, really good millwork engineer, which in turn, I think makes any kind of CAD, CAM, BIM, when you're using technology to illustrate what other people are doing. Not only that, how to inform them instructions, how to do things. I had a really good friend who was a mechanical engineer for Boeing.
Oh, okay.
And
nice.
He, in that type of organization, those guys are not the guys who have experience doing the work. So they have to be able to design and engineer things that give people they're never going to meet or talk to instructions on how to build something. And not only build something, but components of something and put it together. So they would be giving instructions that are like, hey, drill a hole here and you're going to bore it out to exactly 32 millimeters. You're going to take a hole that starts at 10 and bore it out to 32. And if you go half a millimeter past, we're going to have to weld it back and start over. And so that, I saw that. I'm like, okay, I know this is happening in this organization that's making airplanes that can fly. I have to go through all this QC and inspections and stuff. I've got to be able to take a piece of that in millwork and be able to say, okay, there's got to be a way that an engineer can figure out how to create instructions for somebody else to assemble and build something that is high quality work, very difficult to do. And the drawings, the model, that has to be your only way of communication. That's really what this is about. If I have to print a drawing, hand it to a guy, and then go explain everything that's on the drawing to him, my drawing didn't do the job. And I think BIM is very much the same way, is how do we create a model that other people can pull up and look at? They don't know me that did the model. They can get information from it. It is the means of communication. And that's really the ultimate goal of all of it.
Yeah, I love that. I mean, you explained it perfectly, right? If you're making designs and the guy you're giving the designs to can't understand what you drew, then you got to go talk to the guy and be like, okay, what do you need to understand? What do I need to do better? And that's that skill trade that I'm talking about, BIM being a skill trade. I've had my door kicked in by electricians and plumbers, and especially the guy making all the framing and stuff, because God forbid you put the wrong window in the wrong drawing set and he puts it up and now he's got to cut it out or make it smaller. I've been there a few times, right? And you got to take it right on the chin, because he's going to come in being extra pissed because we're not the ones fixing it. He is. Yep. We had to go out there and tell him that we made a mistake. By the way, I made extra work for you.
Yeah.
And so you really learn really quick on how to be more efficient and diligent, and making sure you get the right information on the right page, and making sure you put the right sheet in the right drawing set.
Yeah.
No, that's awesome. Why don't you kind of go in and kind of tell me how you got started with Duck Works? What is that? How did it become? Where are you at now? What do you got going on? That kind of stuff.
Yeah, absolutely. So I spent about 10 or 12 years working in a handful of millwork shops. And so, I was an engineer and then kind of moved, got recruited to a couple of places, ended up managing some departments. And in my last company, it was a startup where we had acquired 5 different shops across the US, and my job was to integrate all the engineering and design across the 5 different locations. So think of 5 different companies that have totally different teams in different regions of the US. Everything operates vertically independent of each other. And now one company is merging them all, right? And so in that, I had about 85 different engineers across all 5 locations. And I was unifying them in software, Microvellum, same way of doing everything, same templates, same library, same data. Hey, this is the way all of us do things, regardless of what shop is going to build them, where it's going to go, right? There's some standards. And after COVID, everybody was remote. And so in our industry, it's very common to outsource the submittal drawings. When you have to do the original shop drawings that you submit up front before you do everything, right? Hey, here's what we're going to build for the architect and GC to review and approve. And a lot of times they outsource those. There's companies all over the world that just do them in AutoCAD, right? Very basic. And it's usually has a lot of problems with it, but it gets the job done cheap and fast up front. And so I had tried all of those and had terrible results. And I said, hey, look, if we're going to do this the way what we're trying to do and really be successful, we should build our own team that we can outsource to and scale our capacity up when we land a lot of work and we need a lot of submittal drawings, and scale it back down when we don't. So through our owner, had a connection in Bolivia in South America that had a business partner down there that's an architect and had gone to school here in the US and done some work here, and now has a firm down there, and said, hey, we can hire architects here in Bolivia and you guys can teach them millwork, right? They already know architecture, they already know design, they already know 3D software like Revit. And so back in 2021, and this was still at my last company, we started hiring, we hired our first person actually in January. And so through that year, we would hire 1 or 2 at a time. And I integrated them as a part of my teams here in the US and said, hey, here's another drafter. They're yours. Everybody works remote here in the US anyways. This person happens to be in South America. They're fluent in English, Eastern time zone. They know architecture. Your job is to teach them Microvellum and millwork and use them as a resource. So that's how it started. By the end of that year, we had 20 people there in that office in Bolivia working full time for us. And it was going really well. We started to kind of figure out through this, hey, we've got standards. So we're just going to onboard you like we do anybody else. And kind of like I explained, okay, I've got somebody that's got a foundation. They understand architecture. I don't need to teach them CAD. I don't need to teach them the software. I just need to teach them millwork. This is kind of what you're designing that's different from just a building.
Right.
And so fast forward to 2023, that company that I was working for sold off. And so sold the business units. And so my role there was ending. And I was originally starting Duck Works just to do consulting. And I said, hey, I've learned a lot in 10 years in millwork. And I know there's a lot of companies out there that I can help. And kind of initially was kind of this idea of, fractional. You've got fractional CFOs, like kind of similar to what you guys do at BIM-TM, like, hey, we can help a lot of people with a very specific set of skills versus just being, a VDC manager for one company.
Right.
And like so that's where it started. And I did some consulting, and then the team that I had built in Bolivia, that company that they were doing work for, sold off. And so they no longer had work from them. And I said, well, I've invested all this time teaching them millwork, teaching them the software. I think I can go sell that to other millworkers and just make a business out of it. So that's really how it started was, hey, we built this team for the company I was working for. And then when that went away, that company sold off. I said, hey, I think this really could be a business that we can service a lot of companies, paired with my consulting. And that started really in April of 2023. And I had built a network and kind of just called some people that I worked with through the industry, like, hey, do you need shop drawings? And we can do it in Microvellum. So that's the other thing that was very common is a lot of times millworkers use Microvellum for their engineering, but if they have to outsource their shop drawings, they're getting it in CAD and then they're redrawing all that when it comes time to produce it. And so I said, hey, look, I've figured this out for myself. We can help you. And it's not just somebody selling you a service that they don't know what they're doing. Like I was in my client's shoes for many, many years, and I want to leverage that to actually do this better. And so now today we really work in two main ways. We do what I described, where we'll just bid a project and we'll give them a price and a schedule.
Mm-hmm.
And client mill manufacturers will use us, like I said, to scale up. Hey, we've landed a bunch of work. It's January. We need 3 months of your help. And then we don't know when the next is, maybe 6 months later. But more and more, we're actually, because this problem of finding talent, like what we described in this industry, is so rampant, we have the majority of our clients now where we have our team members that just work full time with a specific client. So some may just need one person. We have our largest client actually has 12 people that are just integrated as a part of their engineering team for millwork. And we actually, a lot of them will bring to the US. They'll spend a month on site with their client. And then they go back. They've just like a remote employee works here in the US. And so that's really what we've built. We have just over 50 people now in our office. We have an office in Santa Cruz, Bolivia. Wow. We're planning to get to, I think, 80 by the end of this year. We've got a waiting list of clients that are waiting to be matched. So now when we onboard a client and say, hey, we're really looking to get somebody full-time committed that will just integrate as a part of a team, we profile and say, okay, you need somebody that has skills in residential and in microvellum and 3D modeling. And so we're going to match you up with somebody that has those skills in our team, or we're going to train them before we assign them to you. And so sometimes, like right now, we have people that are scheduled to be matched in April, for example. And right now we're making sure that we're getting people the right experience to match to those clients.
That's awesome. I mean, I didn't realize that was the back end of Duck Works, was getting people recruited to the right platform. So do you guys rotate as well? So like when they're done with one company, they can move on to the next one, or they strictly kind of just sit with one company? It's
a mix. Because right now about half our clients are kind of, hey, we've got 3 projects, but we might not have any for a month. And so all that team rotates, and that's really kind of where all of our newbies cut their teeth and get experience. And then we have our full-time clients that are committed, and we have rotated some, like our larger teams, we might keep the main supervisor and leads. And then as their needs evolve, we might rotate in somebody new that has different experience, or we might rotate out somebody else out to another one and backfill them. So, it's kind of the best of both worlds, because one, in Bolivia, architecture is very different, and millwork, like we know it in the US, doesn't exist down there. And so we have both architects, industrial designers, and civil engineers as most of kind of the people we hire. And industrial design down there is like product design, and that really doesn't exist as an industry down there that they can have a professional career in. It's mostly come to the US. So they're getting to do what they went to school for, and working with US clients, gaining experience they wouldn't otherwise get, and really making more money than they could be making as an architect or as a civil engineer. And our clients are getting access to people that are frankly more educated and more skilled than most of what they can hire here in the US, paired with what we've built in Duck Works, which is, okay, decades of experience in the industry, hands-on knowledge, and we can problem solve things with their software, with engineering, that a lot of our clients don't have access to themselves. So, the consulting side is, I spent with 2 different clients today, an hour and a half each of, hey, let me get in, I'm going to road into your computer, I'm going to help you solve a problem with microvellum that they otherwise couldn't solve. And that paired with, okay, we've got people that are going to be able to do this work from you. And then kind of like if you have an IT provider, you might have an MSA of like, okay, we don't need you a full-time IT person, but when we do, we really need a skillful IT person. And right. So us being able to kind of crowdsource it, this is all we do all day, every day. And we really, really are getting really good at it. And it's how can we leverage that for as many clients as possible.
That's really awesome. Well, Jake, I appreciate you coming on the podcast. This has been awesome. I'm sorry if my mic has been cutting in and out. I've been trying to try and avoid that as much as possible. So sorry to our listeners. Jake, where can people reach you? And also, if you're a millwork engineer, you need to contact Jake today. You need to call him up and say, yeah, I heard, listen to that podcast, and you need people, so I'm here. So, Jake, where can they reach you at Duck Works?
Yeah. So you can find me on LinkedIn, Jacob Edmond. And you can find our page on LinkedIn or our website, duckworksmw.com, MW as in millwork. So if you just Google Duckworks, the first one's going to be a boat company, and then you got us, the millwork company. And we've got a podcast, as I mentioned. You can find us on YouTube and all the socials as well. So you'll see the podcast if you like the video on YouTube, or wherever you get them on Spotify and Apple Podcasts. You can listen to it there as well. And yeah, go check out the episode with BIM TM. I think it was last summer, and we talk a little bit more about a lot of this stuff.
I appreciate you coming on here, Jake. Might have you on again at a later date. We'll see. Hopefully a little redemption for this interrupting microphone I have now. So appreciate it. Thanks for coming on.
Yeah, absolutely. Thanks, Alex.